So we are doing these additional notes instead of doing the examples in 4.7. Because I made some of my own examples. I like them a little bit better than the ones that were in 4.7. So when you're done this sheet and another sheet, you can tape them into your book at 4.7 because these are replacing 4.7. These are called max-min problems. And they're actually really cool real-life problems. Some of them, this is the easiest type of max-min problem. It's a word problem where they tell you the formula. So find the maximum height of a ball thrown from one friend to another if its path follows. And this is a made-up equation. If this was a real-life equation, the -2 actually doesn't make sense due to gravity, but that's okay. We're just, maybe this ball was thrown on another planet. Maybe it's a frisbee and there's some sort of air resistance possible, right? But h is the height of the ball in meters and t is the time. We solve for maximum height. First of all, do you see that this is a parabola? And it's a parabola that opens up or down? Down. So if I draw a quick sketch of it, it will look like this. I have no idea where it is, but it would look like that. If you want to find the maximum height, would that not be right there? What's that point called?
Vertex.
Vertex. So max-min problems with parabolas, will it make sense that they always involve the vertex? And how do we find the vertex? By completing the square and changing from whatever form we have to standard form. If we change it to standard form or vertex form, we'll know what the vertex is. And as soon as we know what the vertex is, we will know the maximum height and the time that it takes to get there. So in our question, how do you complete the square? Well, first of all, you factor out the number out of the first two only. So I would get t squared minus 2t, and I keep the 9 on the outside, which leaves a space there and there. The -2 tells us it's going to be t minus 1 squared, right? What would have to be in the first space? A +1. What would have to be in the second space to compensate?
-2.
Close.
+2.
+2. Because we have actually, by putting that +1 there, we've actually subtracted 2. So to compensate, we're going to have to add 2, giving us 11. Yes?
So how come when it's like a whole number, you multiply it by like the number, but if it's a fraction, you divide?
If it was a fraction, let's say that green number was 25 over 4, because we've had that number before, and you had that -2 out in front, and you went like this, you are still multiplying. What's your rules for multiplying? Multiply the tops, multiply the bottoms. You could write this as -50 over 4. But what you saw was me simplifying already, saying, hey, wait a minute, the 2 and the 4 can simplify to be 2 and 1. And then I'd have -1 times 25, which would be -25, and 1 times 2, 2.
So it's the same.
I wasn't dividing, I was still multiplying, but I was simplifying earlier. If I didn't simplify early, I'd have to simplify after. Like 50 over 4 could simplify to 25 over 2. Okay, so I was not dividing. It was good. It looked that way, right?
You simplify.
I was simplifying. Still the same rules, but that's good to see and a great question to ask. And now, my vertex is 1, comma 11. This is always the x that would give you the max. In our question, it's not an x, it is a t. And this is the y, which is the height. So the question was asking what? Find the maximum height. I can write a sentence. And I should include my units. What was my time in? 1 second. And because it's the vertex, the y-coordinate of your vertex is a maximum. Why is it a maximum this time? Because our parabola was going down. So we can find a maximum height, in this case, if we find our vertex. This is the easiest type of word problem because the question gave you the formula. Most of the word problems that we get gave us the equation. Most of the word problems, we will have to create the equation, which makes that the hardest part of the question. Once you create the equation, completing the square, even though it's challenging, you've done it lots already, I hope you're getting good at it. It's sort of like a process. You're like, if you've completed the square and know how to do it, you will be able to do it well from now on. Okay. So let's look at second type of question, number problems. Find two numbers whose sum is 12 and the product is the maximum possible.
If there's two numbers at the top of the screen, is that our questions we're circling?
Maybe. I'll give you them at the end. I think originally, I'll double check. Originally in the homework I'd said that, but I'm going to give you enough questions to practice that. Okay. So, can you give me an example of two numbers that add up to 12? 6 and 6. Okay. So we have 6 and 6. What's the product? Product is what?
36.
36. Two other numbers.
4 and 8.
3 and 4 does not add up to 12.
4 and 8.
4 and 8. Yeah, that'll work. What's the product there?
32.
32. So based on our two examples, 6 and 6 is better. Right? Are there any other two numbers that add up to 12?
12.
9 and 3. That would give us 27. So far 6 and 6 is better. 7 and 5.
0 and 12.
0 and 12. The product isn't going to be very good. We could go to decimals. Oh, I just ruined your lives, right? Went to decimals. It could be. It could be decimals. The question is, which ones make it the maximum? So what we need to do is we need to create an equation. And to create that equation, we have to say one of my numbers is x. What's my other number then?
Y.
And we could say y, but if you make x and y and make an equation, you have two variables.
12 minus x.
12 minus x is going to be better. Can you write both of the numbers in terms of one variable? One number's x, one number's y. There's two different variables. But if one number is x and they add up to 12, the other number has to be 12 minus x. And what do we want to find a maximum of? We want to find a maximum product. So whatever you want to find a maximum of, that's your equation. Product equals. Well, how do you find a product? You have two numbers. You take the two numbers and multiply. Does that make sense? That's a product. Now, if I distribute here, can you see that this is 12x minus x squared? It's a parabola. Which way does the parabola open, up or down?
Down.
Down. Why? Because it's the number in front of the x squared. Tempting to see the 12, right? But the number in front of the x squared, and because it's opening down, the vertex will be a maximum. So I actually might take this and rearrange it with this first. How do you complete the square here? There's a number in front of the x squared. What do we do with that number? Factor it out. we factor it out of this term and this one. Technically, it's not there. If you need to see that plus 0 there to help you out, it's okay. There would be a space here and a space here. What has to be inside?
X minus 6.
X minus 6, which would mean a plus 36 here. And,
Minus 30. Plus
careful,
36.
plus 36 also here because we've actually subtracted 36. Can you see yourself making mistakes in the compensation
So you
part?
forgot the 6.
I forgot the 6, thank you. So my vertex is 6 comma 36. What did this stand for? This stood for x. This is going to be the max what? Max product. So what are the two numbers?
6 and 6.
We were right on our first guess. That's nice when we guess right first, but then some of you would be like, why did I do all that math? I got it right the first time. Well, you do all the math because sometimes you could guess and not get it right. And then you would like a method to find out. Area problems. These are some of my favorites. A man has 80 meters of fence and wants to build a coop or an area for his chickens to be in. And we are going to make it a rectangle. Now, the farmer can use the barn as one side of his coop, and he wants to give his chickens the most area possible. He's like, he likes his chickens. He doesn't want them to be confined in a small area. So what we're going to do is we're going to draw a picture of this looking down from the sky, okay? This is my barn. And looking down from the sky, he is going to build a fence using the barn as one side so his chickens can be in there. He has 80 meters of fencing to start off with, and one of the things that can really help you with this is, can you come up with a specific example? What could be the lengths of this? Like, could he put 10 meters of fence there? What are the other sides?
60 and 10.
60. That makes sense. This would have to also be 10 if it's a rectangle, and this would be 60. Then if you used 10, and I'm going to call that my x, then my area is 600. Not very nice to his chickens? 1. It's like a swimming lane in a pool. How long is that going to be?
6.
No. How long is this going to be?
80.
No.
78.
78. Good. If it was 1, what's the area?
78.
Right. Same amount of fencing used. This would not be very good for your like your chickens would be out of room and frustrated with each other and not very happy. Unhappy chicken make bad eggs. Right? So maybe this isn't a good idea. Now, here's your one chance. What's your guess?
2.
The biggest, we want the biggest area possible.
Oh, we want.
Yeah, we want our chickens to be happy. You get one guess. What are you going to put as a side?
20.
20?
20 and 40.
All right, so this is our guess, area of 800. Now, we're gonna do the math. I wanna see, do we have brilliant student once again guessing 2 times in a row? Well, how do we do this with algebra? With algebra, we say, I don't know how long these sides are, so I choose something as x. If this is x, does it make sense that this will also be x? How much is left for the other side?
80 minus 2x.
We had 80 in total, but we've used up 2 x's, so it makes sense that you have 80 minus 2x for that side. And our area would be length times width. So we'd have x times 80 minus 2x. Does this make a parabola if I multiply it out? 80x minus 2x, yes it does. And does it a parabola that opens down? Absolutely, so our vertex is going to be our maximum. And whenever we want to find our maximum of, so we want to find largest area, that tells us you need to make an area equals equation. If you make an area equals equation and you have a vertex, that's going to be the maximum y value, which is in this case the maximum area. So for all these word problems, the question, whatever they want you to find a maximum or a minimum of, is what you have to set your equation up as. The hardest part is done now. Setting up the equation is the hardest part. And from here, I'd write the x squared part first, so I'm going to rewrite this as negative 2x squared plus 80x. So how do I complete the square? I take out the negative 2 out of the first 2. Leave a space here. There technically was a plus 0. Leave a space here. The minus 40 is a hint. What does it have to be?
20.
Minus 20. And if it's minus 20, what number goes in here?
400.
But what have I actually done?
Subtracted 800, so plus 800.
Are you smiling yet? And so our vertex is
20 and 800.
20 and 800. This is your x. This is your max area.
Whatever.
So what should the dimensions be?
He's brilliant.
What are they feeding the German kids?
20 meters by 40. Whoops. 20 meters by 40 meters. What did the question all ask? These ones that I find I often have to reread. What dimensions will yield the largest area? Dimensions 20 meters by 40 meters. Sometimes they'll say, what is the largest area and what's the dimensions? So then you have to answer 2 questions. The largest area is 800 meters, and the dimensions are 20 meters by 40 meters. Whew! Yes?
So on a test, you could probably just guess, but you would prefer us to plot out
I
and
think
actually
we
show
get
them.
marks on the way we calculated it.
Yeah,
that's
you
what I
could
thought.
probably just guess. And then
You get a bit of
and you
mark.
get it right, and then I would guess what mark I'll give you. And I usually don't guess 3 out of 3.
Would I get 3 out of 3 marks if I don't calculate anything? I just guess something.
You have to
But
show.
I could guess something and then plug it into my equation.
But how would you know it's the maximum?
Don't play the game.
Right?
This is guessing is good.
And do you know what the problem is? If guessing gives you full marks, then what happens is the teacher, this is like historically, the teacher gives a question and they give full marks and they're like, oh, he guessed. I'm not happy that he guessed. So then what does the teacher do for the next question? They make one that your guessing can't work. You have to use like quadratic formula. And the answer is 21.372. Like, oh,
Just guess that.
guess that. right? But then the teacher has to give the student 0, and then they feel bad. Because the only way I can stop you from guessing is I make a hard question, but if I make a hard question, then you all get it wrong, and then I feel bad. So instead, I make the nice question, where you
Just make
could
the
guess
nice
to get the
question,
answer.
give us more
So you
kind of
feel like you know what the answer is, but you could show it. In fact, I could show you a shortcut where you could tell the answer. I could, right? Change this number, 80, to anything you want.
120.
120, the dimensions will be 30 by 60, maximum area. Here's a shortcut. Some of you might figure it out. But you still have to show your work. Give me another number.
67.
67. Whew!
Divide by
Then-
2 and divide by 2
Yeah,
a second
yeah.
time, and then you've got
Yeah, it'll be 23.5 and 12. 11.75. That would be the answer. So there is a shortcut, right? But then I can make this question more difficult by saying, oh, the farmer has white chickens and brown chickens. And the chickens don't like each other.
Oh, they're racist.
Oh.
Man.
Racist chickens. It's
Yeah.
so bad,
And
Is your
they
video
have
going?
brown eggs and white eggs.
right? Brown, yeah, it's like, things are not good.
The brown chickens are not allowed to cross the border.
So
Oh.
they put up a
That's
wall.
what the farmer said.
So we can get into a whole bunch of politics and ethics with this question. But I could add a divider.
Brown chickens will pay for the wall.
There we go.
The white man talking about the brown chickens to cross the border.
There we go. We just went into history and ethics and sociology and But you could have a section there, right? For different ones. Or maybe you have more than just chickens. You have a farm of chickens and foxes. And first you thought they would be okay, and you had one fence. And the chickens ate all the foxes. Right? So you had to build a divider. So the chickens were on one side and the foxes were on the other. Then this is a new question. What would I have to change if there was 3 dividers?
80 minus 3.
80 minus 3x. And now the completing the square is going to be different. You could good. Yeah, all sorts of crazy things happen. So these area questions, though, are kind of cool because what you just did was you had the same amount of material, but depending on your choice, makes a different size. And we stuck to rectangles. We could go into calculus and say, well, what if you didn't have to use rectangles? You could still using the barn is smart because that's extra, but what shape, what would you do if you were not restricted to a rectangle?
You gotta make a large oval.
You make a large oval, like this one, an octagon.
That's still a rectangle.
Right? Could take art lessons, there's all sorts of things. Okay? There is a shape though that would make it even better.
Oh,
You could
Circle.
Okay, but what? Try it. We could do it this way.
That's too hard.
That's too hard. What would you need? You would need you would need half of the circumference to equal 80. And a calculator, and to find the maximums. In this case, you might need calculus. You guys are only 2 classes away. Yeah. Okay. We did the area problem. And the most complicated ones I find are the profit ones. And if you like to go into business, as a real life and like to take advantage of people and make as much money as possible? This is your kind of question,
74.
okay?
Yeah, that's not my question.
So,
I'm listening.
the school sells sweatshirts for $20. That's actually a pretty good price. At that price, they find out 300 students will buy it. Okay? If they increase the price, some people will say now it's too expensive. So if they increase it by $5, 30 less students say I'm going to buy it. But you being the shrewd business person, the principal who wants to make the most money off the students possible, what price should you set so the school makes the most money? You don't, as a business person, you don't care that everybody gets to experience the nice sweatshirt, right? This is like a sports event. There's a sports event coming. What price should you charge for the sports event? It's actually sometimes better to have empty seats that nobody paid for, right? Like if you were at the Jets, if they set ticket prices at $8 billion, nobody would buy it. But if one person buys it, they'd be like, this is so good for us,
I don't think the Jets are.
right? Be a really sucky game, that one person was like, I don't know, wearing their gold suit or whatever, sitting in their special spot,
Not anymore.
okay?
Isn't this an inequalities question?
It's not an inequalities question. Because how do you figure out how much you're going to make? We want to find, what do we want to find a maximum of? A maximum profit. So let's just start off thinking about how would you calculate profit? Like if we did the 300 students and $20, how would you figure it out? How much money did they make?
300 times 20.
300 times 20. Would you agree that, I'm going to write it out in words, it's like the number sold times by the price?
Yeah.
And we started off with selling 300 for a price of 20. Yes.
Now also lower the price to get more students.
You could also lower the price. That might be. So I'm going to introduce.
Take a guess first.
Yeah.
Well, we're going to get to the guess in a second. We're going to let x equal the number of price changes. So if you change the price once, what would the price become? 25. If I change the price once, the price goes up by 5. If I change the price twice, it would go up by 10. What happens if I change the price once? Number sold goes down by.
30.
If I change it twice, it would go down by 30 twice. All right. Flex that guessing skills. What do you think? You're not allowed to do math, you have to guess. What should we sell these hoodies for so the principal can make the most money possible?
15.
$15?
Yeah.
All right, so at $15, how many people will buy? 330. Max profit then, this is our guess, 15 times 330, $4,950. And secretively, everybody in the class is hoping Henry guessed right.
I didn't.
You didn't? How do you know? Why would you guess wrong if you had a chance to guess?
I'm just generous.
You're like, I want to lower,
Yeah.
you wanted more students to be happy. You think your principal wants?
No, I
Oh, now we're getting into a new discussion.
wouldn't make a
And I've got this on video, so I better be careful. All right. So what would we have to do? We have to see, is this a parabola? Well, I'm going to multiply it out. 300 times, that's $6,000. Oh yeah, that's a bad
That's
You're already at the 300 level. You would have made
Can I
more.
take another guess?
Okay, you want another guess?
30.
30. If you did $30, how many are sold? You've gone the price up twice. 240? 7,200. That's better guess. Okay. 600. And this would be plus 1,500x, right? Minus 600x, and then minus 150x squared. Whew! There's some big numbers there. Do you see that it's a parabola? What's the number in front of the x squared?
150
Negative 150. Is it going to have a maximum? Absolutely. So I'm going to rewrite it with the negative 150 first. These are like terms. That will give me plus 900x and then plus 6,000. How do we complete the square? We have to factor out that negative 150 out of the first two, leaving x squared. How many 150s in 400?
6.
6. So it'll be minus 6x plus 6,000. Negative 150. This will be x minus 3, which means in this space you would have a plus 9. What goes in this space?
Oh,
wow.
big number.
A bigger number.
Are we gonna
1350.
You get a calculator on this one.
1350.
Plus 1350. Oh, Henry's run has come to an end.
It was looking close.
He was getting close. What is our vertex? Our vertex is 3, 7350. This is the x. This would be the max, in this case, profit. Max profit. Careful. What price should they sell it as? 35, not 3. Sometimes I have students say, they get the vertex, they should sell it at $3. I'm like, no. What did X stand for? We made the X the number of price changes. There should be 3 price changes of $5. So the price should be 35. That would mean only 210 students would buy it.
I don't care about that because we get more money.
You only care about getting more money. $7,350. This happens all the time in real life. Companies, do they care about people? They say they do.
They don't.
But at the end of the, what do they most care about?
Money.
Money. Okay? They want to make the max profit possible. What happens if a company is the only one selling something? They have a monopoly, they can charge a very high amount, right? Then you need another company that provides competition.
High demand, low supply.
And then you get like supply and demand and all of those things involved. But then both companies, even though they're competing with each other, both still want to make the most money possible.
business class?
Yeah.
So they buy each other out.
This is fun. You went from a racist chick and